Welcome everyone to another session of Your Desk University, bringing you live learning with AEC tech experts directly to your desk. My name's Tim and Hazel. Tonight we talk about data. Data. Eileen Phan from Walter P. Moore will be sharing about how to use simpler methods to help get more people involved. What originally started as an interoperability tool, it can now be used for so much more. If you're having any struggles with getting data out of Revit or using it or getting more people engaged, I think you'll find this show will be really helpful for you. Nan, you can see next to me, I have Dana DeFilippi. Dana joins us from Smith Group and is a #1 rated speaker at AU and an avid Dynamo user. With that, I'll turn it over to her as she hosts our show and introduces Eileen to you. Bye, everybody.
Thanks, Timon, and thank you everyone for joining us tonight. As Timon mentioned, my name is Dana. I'm a BIM technologist at Smith Group. Your Desk University has had 9 really epic conversations so far, and we are about halfway through. Our series finishes off June 9th, and we are finalizing the details on the last presentation, so please check out our website. Once again, thanks again for joining us tonight. Please also join us Thursday for a presentation on building secure operational web application prototypes using Airtable and Google Apps. As a side note, our website, yourdeskuniversity.com, is using Airtable. As Timon mentioned, tonight we have Eileen Phan with Walter P. Moore talking on data and simplicity. We all work with data, the I in BIM, right? And Eileen will show us Walter P. Moore's interoperability tools and how they store data. As always, please post your questions in the chat so this is interactive. Of course, if you aren't able to be with us live, please post to the comments below. And now to our speaker today, Eileen. Hi, Eileen, how are you today?
Hey, Dana, I'm doing well. Thanks for hosting me tonight.
Absolutely, thank you for presenting. Tell us a little bit about what you do outside of BIM. Anything that you can tell us what you've been doing during quarantine?
Yeah, definitely. So, I have like a really big sweet tooth, and I used to like check out all the bakeries in the area, like buying cakes, pastries, and whatnot. But you can't really do that anymore. So I've been trying to bake a lot more at home. Next on my list I have is what was it? The Disney churros. They just released a recipe for that. So I'm gonna be trying that this weekend.
Oh my goodness. Do you have an Instagram page or anything that you post to?
No, I'm actually not that much on social media, so everything's just on
Oh,
my
you should
phone.
totally. I would love to get the churro recipe. I love churros.
Yeah.
So if
I'll
you,
let you
we
know how that turns
must
out.
share that. Absolutely. Thank you so much. Any
Yeah.
beginning words that you want to share before you share your presentation?
I would just like to
Jump
emphasize
in.
like how simple this is, and I hope you guys all pick up something and can utilize something from this presentation. All right, so like Dana mentioned, today I'm going to be talking about how simplicity can be used by others. And the overview of the presentation, I'm going to start off with interoperability, discuss how that was a problem, and then the CID would be how we have the solution for the interoperability problem. The following 4 topics are going to be quantity tracking, CID comparisons, change management, and data visualization. So those are kind of just like how we've started using the CID after we've used it for interoperability. So some of these topics, I'm going to be showing you examples in the slides, and some of them are going to be kind of like live demos. So we'll go ahead and start off with interoperability. So here we have on screen why interoperability, like why do we need it? So you can kind of see one whole building here, but the 4 different sections of the building are from 4 different programs. So on the left, you have what was developed inside of Rhino and Grasshopper for our parametric modeling. In the center, you have your Revit model for documentation purposes. At the top, you see our analysis model. So that's where all of our design comes from. And then all the way on the right in the red is our Tekla model. So that's the steel fabrication model. So interoperability starts with, you have 2 programs. How do you get them to talk to one another? And then, after you figure out the solution between that, you kind of add more to the equation. So now you have like 4 programs, and once you get those solved, there's always more to add to it. And it starts to kind of look like a spider web, right? And the issue with where you see this is it may not be hard to kind of create a definition to talk from program to program, but where it starts getting a little hairy and difficult is when the programs get updated, new new software comes out, like the API changes, and you're gonna have to like manage these definitions and like always update them, and it could get a nightmare. What was our solution to the interoperability problem? So now I'm introducing you to the CID. So what exactly is the CID? So it's an acronym and it stands for Central Information Database. So now you're probably wondering like, what is the CID and how does it fit into like the spider web that I just showed you earlier? And the name kind of gives it away, it's central. So it's going to be smack dab in the middle here. And so now it kind of looks a lot less like a spider web, looks more kind of like a flower, a lot more clean, a lot more simple. And because the CID is kind of like so flexible, you can keep adding on different programs, utilize a CID. So up next, we have an example, a project example. So all of these programs, the 4 programs were generated from the CID. Well, I should say one of the models produced the initial CID, and then the 3 remaining models were generated from the CID. The CID can store, like you can see in here, the CID was storing like a lot of geometry, so we're pushing geometry from the different softwares, but you can store any other metadata that you want inside of the CID. So now you're probably wondering like, how do I get this CID? So
Yeah, what does that even look like, right?
yeah, exactly. So the CID can be extracted from multiple different programs here. So I've listed them here as like icons. You can get them from like the softwares, Tekla, your fabrication model. You can get it
Ooh, Rhino
from
inside. That's a fun one.
yeah. That was like one of
All
the
kinds of fun stuff
newer
up
ones.
there.
hmm So you can extract it from Dynamo, you can extract it from your analysis models, and all the way on the right side, we also have something called PyWally. So that was our internal tool created. It's kind of like PyRevit, but with a Walter P. Moore spin on it. So we're calling it PyWally. So up next, I'm going to be showing you what the CID actually looks like. For now, you're probably just wondering like, what is this kind of like black box? So it's as simple as an Excel file. So you can see here, it has a bunch of columns, a bunch of rows, and this is the database.
That's
So
some great looking data right there.
yeah, so it has a lot of information. You can see that it has like the vertices, it has information for the lengths, the releases, and whatnot. And so I'm going to show you guys how to kind of extract the CID, and then once we extract it, then we can kind of like open it up and kind of look at the data inside of it. So here you should be seeing Revit now, and this is the model or the building that I'm going to be extracting to CID today. So up here at the top, we have right next to our PyRevit toolbar, we have PyWally. So over here, we have Revit to CID here, and we'll extract everything inside of the view. So it
And
doesn't need to be
PyWally,
as,
is this a paid program or is this something Walter P. Moore created?
it's
I'm
something that
guessing it's
Walter
a
P. Moore
Walter P. Moore.
created. Yeah, yeah.
Okay, that's an
So
awesome name.
I'm
And
glad
it
you
looks
like
like
it.
some agree.
Yeah,
Carl
so
Storms, the BIM Insider, agrees.
thanks. So this was kind of this is like relatively new. It's about half a year old now. And before we had this like nice fancy toolbar that we do now, we were extracting everything using Dynamo. So with this upgrade here, we're seeing that, extracting these CIDs are a lot faster, especially when the amount of information that you have is quite hefty. Saving my CID here now to my folder, and we can kind of open that up and see what's in there. So here we are, the CID 1 that I'm calling it. All right, so in the first column here, what we have is what we're calling the Walter P. Moore Index. And this is kind of like a unique name that we assign to every single member of our project. So up here at first, you can see that these are assigned to a bunch of columns. And this is kind of like a social security number that you apply to an element instead of using the element ID or the GUID. It's kind of a unique name that gives you more information about the member rather than, a bunch of numbers. So as we scroll to the right, you can see that there are some vertices here, the start and midpoint, and then following to the right, there's a bunch of just like other metadata that you can push to other programs. you might not need all of them, but it's nice to just have them all here. And in the next couple of slides, I'll show you how I utilize the rest of this metadata.
And stepping back a second, back to that index number that
Yeah.
you were just referring to, that actually seems like a brilliant idea, right? Because if a column or whatever kind of
Mm-hmm.
data it is that you're extracting, let's just say that you delete it and a new
Yeah.
one's created, well, now that has a new element ID, it has a new GUID, right?
Yeah,
So
yeah.
keeping it as a self-contained index that you guys maintain is brilliant. That's really
Yeah.
fantastic and a great idea.
Yeah, exactly. It's like so easily controllable by the user, and you can kind of like add any information in there that you want. So like from project to project, you could get different naming conventions in there. Yep.
Fantastic. And once
So
again, just a wonderful way in how we think about data, right? Like, once again, it's like if that column gets deleted, well, how do I track the new one? How do I know that that new one replaced that old one? How do I know where that old one went, right? So that's
exactly.
brilliant just in itself.
Thank you. So now that we have the CID here, I'm going to show you guys how to get from Revit, where we extracted our CID, into our fabrication model, Tekla here. So I'm going to be using Rhino for that, Rhino and Grasshopper. So on the left side here, you see my definition. So I'll just load in the CID file to read. And over on the right side, you should see kind of like a preview of what's going to be pushed out into our model. So and of course, it's not showing up because I have this open. So got to
Well, and
close
that's just
this.
the way live demos work too.
Exactly. I should have been expecting this.
Of course, yeah. All of the things to go wrong go wrong.
All right.
Oh, very
So
cool.
now that I closed my CID file, you can finally see it in here. So we can kind of like spin around it. It's kind of just like a stick model here.
Which we
And
see that in Dynamo too, right? Like if you have your Excel file,
Mhm.
it may not be able to be read when it's run and all that good
Yeah,
stuff. So all
exactly.
familiar with that.
All right. So now I'm going to bring up my Tekla.
And so remind us where the data from the Excel file came from. That was from Revit itself
Yeah,
that
it
you
was
exported
from
that data? Okay.
yeah, it was from
From
Revit
the
itself.
Pi Wally tab, of
Yep,
course.
from the Pi
So
Wally here.
and so essentially the Pi Wally tool has been established to essentially export consistent data, correct?
Mhm.
So that
So
when you go through there, it's always going to maintain that level of data to be shared.
yeah, exactly. So the data that you get out of here is consistent, but it's also flexible to where, you can kind of change the type of data you want export from like project to project, or if you ever want like additional metadata, you can add it. And we do that through a JSON file, which I kind of like skipped through really quickly earlier, but very customizable.
Mm-hmm. Awesome. Or we could do this a number of ways just to export that data that we need, right? To
Yeah,
create
yeah.
that CID.
So
Right.
exactly. So like in my previous slide where I showed like the different programs that we used to extract like the CID from, you can do it in inside of Revit by just like a schedule, a Revit schedule if you want, or you can use Dynamo. There's just like depending on like what kind of data you want in there, you can, as long as you get into kind of like an Excel format, it's and it does something similar, then I think you're okay without the PyWally tools.
Even I think using Revit, the export schedule tool, right? You can export reports. You just can't import
Yeah.
them back in. You might need something like BIMlink or something like Dynamo to get the data
Mhm.
back in, but you can definitely export the data. So don't necessarily need the PyWally add in there,
Yep,
which is awesome.
exactly right. All right, so now that we have the CID read into here and you see the preview on the bottom right here, we're going to go ahead and instantiate this inside of Tekla. So first off, I'm going to try and do the beams, all of the framing here. So I'll right click and enable that. So you should see it pop up here. The beams will take a little bit longer than the columns just because there's more of them. So here we are. See that? And then I'll go ahead and do the columns down here.
Now, are you, excuse me for not knowing Tekla, but are you using Rhino inside or is there a Grasshopper plugin to Tekla? How are you, or
So-
does Grasshopper just talk to Tekla?
This is a great question.
Like through Rhino.
Yeah. So like inside of the Grasshopper definition here, it's not Rhino inside. It's just the regular Rhino and Grasshopper that you have installed separately. And
The Rhino
we're talking
outside, I guess.
Yeah, exactly. Rhino outside. So what we have is just like we're talking to the API of Tekla here. So we're able to just kind of like use a lot of like the out of the box nodes in here and kind of manipulate the data and then do a little bit of coding to talk with the API for Tekla. And then that's how we're kind
talk
of like
about
pushing
simple,
here.
Eileen. That is fantastic.
Yeah, so a lot of these
just
nodes are out of the box and yeah.
Wow.
Anyone can kind of like build something similar. So I'm gonna disable that and give this like a quick spin around here. So if I click on any of these beams here, you can, or columns, you can kind of see like all of the data that came with it. So it came in as the correct size. It has a material and whatnot. So this is just kind of like some of the metadata that comes along with the CID. So if you had additional information, you can populate it in here as well. All right, so we went through our example. So next up we have is quantity tracking. So now that we have the CID as our solution to interoperability, what other ways can we use the CID? It's like such a simple Excel file. So what else can we do with it? And where we're doing quantity tracking, I'll show you guys an example of it. It's going to be inside of Power BI. So over here, you can see that I read in a CID file. So similar format, you know, it has the Walter P. Moore index here, along with some additional information, the geometry and the vertices column here, and then some more metadata to the right. So you can read that in and kind of like digest your information inside of Power BI. Sometimes like when you have all the metadata and whatnot in like your analysis programs or a Revit model, you have to like kind of click on the member and kind of like see what kind of information belongs to that member. And it's kind of hard to digest all at once when your model gets really big. So it's nice once you kind of like throw that CID file into Power BI and kind of like get a summary. So the first thing we're looking at here is, you know, it can tell you how many elements are in your CID, what is the steel tonnage of everything inside of your CID. And if you want more detail, then you can kind of like break it up too. So on this page here, like you can see where the tonnage is coming from, how much steel tonnage is in from columns, how much are from beams, how much are from braces, and even the sizes. So on the next page here, like delving into like more detail, you can look at where like what members are causing the steel tonnage to be so high. So at the top left here, you can see that W18 by 35 is widely used in the project. It's a huge spike compared to all the other members over here. And you can kind of see just like the differences in the member size that you're using, kind of like go back, and project managers really like this. You know, it gives you a great summary of what's in your building, and can you kind of like optimize it from here? Can you eliminate some sizes? Like, do you really need all of this? So Power BI is
Making
a
it
really great way.
super easy to read, right? Just
Yeah.
amazingly incredible, not only to visualize, but to like you said, to just be able to see the spikes where they exist and etc. It's really fantastic.
Yeah. So really, really easy to read everything in here. It has nice graphics too. So
and another program that you know I have just dabbled in here. I know that Eileen and I chatted about how we're both new users of Power BI, but you can find some really great YouTube videos and stuff like that to get you started. And it's, I find, much easier than visualizing in some other programs like Excel, for sure.
Yeah.
When you say?
Yeah, definitely. And you know, this program is just like free too. Like if you have like the Microsoft Suite, then you don't have to pay anything additional. You can just get like the Power BI desktop, download it, and you can use it right away.
Yeah, definitely check that out. We all have Microsoft Suite, right? More or less.
I hope so. Yeah.
So we have a question here from Zhao. Hopefully I'm saying that, I'm pronouncing that correctly. Have you heard of the Constru plugin?
I have. I've never actually used Constru myself before though. So not too familiar. Yeah, that is very true. So I think construe is kind of like, I think what we prefer is, if you have like your internal like development of all of this, then you can kind of control it, and you're not afraid of like, like it going out of business or something changing and it's like not to your fitting. It's kind of like if
Right.
you wanted to do something, then you can kind of program it, develop it to do what you wanted to do. You're not limited to other programs. Like if someone's giving you something and it does this, but if you want more than that, then like it's kind of like hard to get that. So it's kind of
Sure.
easier to do something internal, in my opinion
Absolutely. And then
anyways.
also you don't have to worry about fee structures and,
Yeah,
the
exactly. Those fees
licensing
stack
changes
up.
next year and all that stuff. I mean, and then sometimes it's like, oh, well, if you run it more than once a day, then we end up running, it's like more tokens are used up. So like you said, it's
Yeah.
almost a limitation in how you can use the data.
Mhm.
So it absolutely understands. That makes perfect sense why you would want to internalize that. Absolutely.
All right. So next, now that I showed you guys like what we were doing for quantity tracking, this was another example from one of our projects where the user kind of exported SIDS on a weekly basis. So you can kind of see on the bottom left here, a weekly export is created, sometimes multiple times a week. But this kind of helps you track the steel tonnages during the lifespan of a project, how it goes, how it increases and how it decreases. So that's just some other ways where we weren't expecting other people to do what this did, but it kind of just like came naturally since it was kind of really easy to use.
Yeah, seems super simple.
Yeah. So up next we have CID comparisons. So exactly what it sounds like. We're taking two CID files, from two different points in time and comparing it to one another. And this one can be done, or what I have examples of is inside of Power BI and inside of Grasshopper. So this kind of just like emphasizes like how easy it is to export the SID and to utilize it. So my first part is going to be inside of Power BI. So you can read, oops, you can read the two SID files in here and kind of like get a summary of what has changed. So over here, everything is mapped based on the Walter P. Moore index. So if you have two SID files and you see new indices like pop up, then you definitely know that they're new. If they're missing, then they're deleted. And then any remaining index are kind of compared to each other to see if their geometry changed, if their metadata changed. So all really simple to do inside of Power BI. So the first part we're looking at here is just like a summary of all the elements that have been deleted between the two SID files that I've exported. The first SID file was the one that we exported together earlier. And then the second SID file is of the same building, but a couple of weeks later. So we see here that in those couple of weeks, 427 members have been added and 2 members have been deleted. There's a total of 1,392 elements inside of the SID. So the remaining items, 965 have have been matched and have either moved or have stayed the same. So you can kind of like create these toggles in Power BI and filter your data. So here, I wanted to check what elements have moved within a specified tolerance here, and you can see that 21 members have moved.
Wow, this probably makes your job so much easier, doesn't it? In terms of coordination, I can only
Mhm.
imagine
Yeah.
how, I mean, just being able to coordinate that and just a visual, clean,
Mhm.
fast, and efficient way. I mean, goodness, that probably, I mean, I'm obviously no structural engineer, but I can only imagine the amount of time that saves you.
Yeah, so that is when you mentioned visualization, it's nice to see all of the data here. I can click on one of these beams and it'll kind of like filter it so you can see what the position geometrically was before. Like this is the start and end point before, and this is the start and end point now. You can see the numbers may have changed here, maybe slightly. But the issue with kind of this is you can kind of see a summary, but it's not too visual where you can see like where exactly is this beam located in the project and like, why did it move? So
Sure.
this is like a
More of a
good
starting
overview.
point, like a
Yeah,
summary, right? Like,
yeah.
but a
So
fantastic one.
thank you. So the next one I'm going to show you is the same thing, same concept. a CID comparison, but we're going to be using Grasshopper. So let me switch this here. So this is just another definition here, and on the top left here, I can read in my two CID files. So again, the first one was the one that we exported together. The second one was the same export, but a couple weeks later. So we can toggle that to read the CID files, and hopefully I'm out of the CIDs this time. So let's zoom in to see what we have. So
So
here,
quick.
yeah, very quick. It's very light to read all of these CSVs. So over here, you can kind of see like there's a whole bunch of different colors here. So what this is the greens are all of the newly added members. The red are all of the deleted members. So this kind of like matches up what we saw before in the Power BI saying like two elements have been deleted. So those are the two columns. And then all the other members here, you can kind of see in yellow and a bluish color. Those are the members that have slightly shifted. So not sure how well you can see this, but they're kind of overlapping, kind of not. So you can kind of see that they shifted a little bit. And
Sure.
again, this kind of emphasizes that because a CID is like so easy to use, like depending on like it doesn't matter like what your experience is, like you can throw it into Power BI, learn it really quick. If you know Grasshopper, that's great. You can build a definition, something similar to this, and kind of digest your data. And if you're like super into programming and maybe know like a little bit of Python or a little bit of C sharp, you can also do something inside of Grasshopper and create your own nodes. So this kind of does the same thing, but it has extremely less nodes in here. I'm still reading in my two CID files that you see here, and you can visualize the CIDs. So this is the CID from my second file. If I copy that, look at my first one, kind of toggle between the two, you can kind of see like, oh, here are like the red elements that appear, and those are the same as what we saw before, all the ones that have been added since we last exported the CID. And you can,
So
this is like
essentially
the,
doing what the Power BI did, right? Just
mhm,
looking through the Excel and identifying those the index numbers,
yeah,
right? I forgot
exactly.
what that was called.
Yeah.
Um, for what's missing, what's new, and what still exists, right? And then
Yeah.
comparing what still
Yeah, so
exists.
all of this has like the same kind of logic. You're taking the Walsh-P-Moore indices, comparing it to one another. So, it's really important to have like good data so that like these indices like aren't lost and like recreated. Like once you assign it to a member, then that's like its name, its social security number. It can't change.
Absolutely. And so on that, would you say that you have methods in Revit in particular where if, maybe something that ensures that that number is being maintained,
Hmm.
like a back end, maybe like a script that will renumber on demand, or something that's constantly renumbering as you go? Or is it just something as a modeler, I need to make sure that identification number is accurate?
Yeah, so these are actually like sometimes it's hard to maintain when everyone is inside of the Revit model. It's not just yourself. So a lot of people are like copying and pasting members and not like forgetting to delete all of these. So sometimes
Sure.
it's kind of hard to maintain, and sometimes you get duplicates of these members and you have like more than one element with the same ID. So in those cases, we have tools inside of PyWally where it'll flag it if a member is a duplicate. And it's not it's kind of difficult to say, like, fix it, like, this was, like, the element that the index originally belonged to, and the second element is the one that needs to be re-indexed. Sometimes it's difficult, sometimes you can kind of assume that based on, like, the element ID or the GUID, which one's, like, a higher number, you can kind of, like, guess which element was created last, but sometimes
Hmm.
it's not always the case maybe. So, we'll kind of have to, like, compare it with, other models, like, kind of what I do is, um, if if my driver model is Revit and I know other models exist, like I have my analysis model and I have my Tekla model, if I find like a duplicate inside of your Revit model, then I'll have to like double check in one of those other models to see which one was actually the original member, if that makes
I
sense.
see. And would you say that your originating model is typically Revit, or would you say that you derive your data from another um, database
Yeah, so
consistently more often?
that's a great question. So because of how the SID is structured, anything can be your driver model. Sometimes it's Revit, sometimes it's Grasshopper. Like, if you're creating a building parametrically, then maybe your driver model is Grasshopper and you're doing all the indexing there, and then you push the final geometry into Revit. Sometimes you start off with creating analysis model first, just to see if it works, and then if it works, like throw it into Revit afterwards. But sometimes you'll just create a Revit model first and then like put it into analysis. So depending on the project, the driver model can change, and yeah, it can't be Revit in some cases.
And that's the beautiful thing about the SID, right? Is that you're still,
Mhm.
regardless of where that information is being derived from, it's maintaining consistent properties to it, right?
Yeah,
That
exactly.
you're always asking for the same information.
Yeah, exactly. Any of these programs can accept a SID. Any of these programs can get a SID extracted from it. So it doesn't really matter where you kind of start from. You can always go somewhere else.
That's so awesome. And like you said, like it's called simple, right? Couldn't
Yep.
get more simple than that.
Yep. So I'm just gonna show you the final parts of this node here. So this node was built internally at Walter P. Moore using C#, and you can kind of just like visualize each part really quickly. So you can see these are the members that have changed. These are the members that have been removed, and these are the members that have been added. So just as a quick QC, let's see how many are in here. So it says 427 members have changed or been added. So we go back into our Power BI and we go to the new. Yep. So you can see that the data is consistent. So that's always good.
So Zhao, who also asked about the Construct plugin, agrees that this is brilliant and
Thank you.
asks if this is only used for steel structures at Walter P. Moore.
It is not actually. We're using it. So my example, I was using steel structures, but we're using this for concrete as well. We even created our own analysis program for concrete, and it only accepts the SID. So there's no interface where the user can draw a beam. It only accepts the SID.
Oh, wow.
So we have that, and then we can also export foundations and base plates, walls and slabs. So you're not really limited to just like steel structures. Like if you're from a different discipline too, you can use this and like export like doors or something if you want. So it's whatever you need. So we just finished up with our CID comparisons and our example for that. And so up next, we have change management. So this is kind of like going off on the CID comparisons. And for change management, it's very important. Every project goes through it. Like you need to know like what has changed, why it has changed. And the way that we've been doing it is CID comparisons, whether it's in like Power BI or inside of Grasshopper. So I'm going to share with you guys a story for a project here in Virginia. So this kind of looks familiar here. I just had this exact definition pulled up inside of Grasshopper. So this is what we were using for the project. And what happened for this project was
very clean.
A couple of years ago when
very
like,
organized.
Yeah, thank you. Yeah, that's also the importance. Like if you're going to create these tools and it's kind of like messy, then it's kind of like intimidating to use. You don't know where to start.
Even for you sometimes, right? I feel like sometimes when I create a script a month later, when I go back in, I'm like, why didn't I organize this? Which never happens. I
know. I feel the same way too. And I always regret it, but I never learn from it. It's kind of like, I just need to do this like really quick and dirty so I can get it to work. I'm not going to use this again. You come back to it and you're like, what was I doing here? Yeah.
Right. Exactly.
So
it's really, nothing else
really
for
nice.
yourself.
Yeah, exactly. If nothing else for yourself. So for this project here, the steel tariffs were increasing. So we placed our mill order really early. And, by the end of the project, what we had for final like steel tonnage and whatnot did not exactly match up with our mill order. So this is kind of the story for this project. You kind of did a CID comparison, and this is the outcome for one of the CIDs here. You can see that these are all the framings from a CID. And now, if you're comparing it, these are all the ones that change. So that means that from the mill order till the end of the project, that these members changed some shape or some form. So working with the fabricator, they said that they didn't care if they only cared about members of a specific size or series. So using Grasshopper, the data was easily filtered out. So now you have less members. These are the only ones that they cared about. And then the fabricator said, I don't really care about any changes that are less than 6 inches. So we'll go ahead and filter that out using Grasshopper to just manipulate the definition a little. So now this is what is left. So with the remaining on the screen, you can kind of like pinpoint back to like, why did we change the steel sections from these different areas?
And then of course, as you're showing here, understanding the impacts as the project continues and progresses, what those impacts were on the structure, which is, I mean, that's just fantastic that you're able to visualize it in that way.
Yeah, exactly. And what I've seen is helpful is like to keep up with the change management. It's good to export CIDs on a frequent basis. So if you have like daily exports of CIDs, you can kind of like see what's changing on a daily basis. Like there's other things that you can do to maintain it, but we've seen that like CIDs are really easy. But so let me tell you a story what just happened like a couple of weeks ago. One morning we came in and a bunch of like steel members were missing and no one knew what happened to them. And like, did someone just
Of
delete
course.
them? Like what got
Yeah.
deleted? Like how do you bring it back? Just like, just randomly, like things like this happened before a deadline, So what we did was we've been exporting CIDs on a daily basis. So then, it's really quick. Just open up Power BI, do a comparison between yesterday's and today's. You find out immediately like what has been deleted, and then you can bring them back easily. So like
Oh my
you
goodness.
even using the CID from yesterday, you have all the information there. So like you can just reinstantiate it. So
Well, and
really, really
I mean,
nice.
it happens to all of us, regardless of what discipline we're in, right? Stuff
Yeah,
disappears.
exactly.
And
Uh-huh.
it's even, you might think, hey, I think I got those 4 columns that disappeared. I think I got those back. But that
Hmm.
is just an amazing feature to be able to just say, let me just double check. Let's go ahead and do a
Hmm.
compare of what's in there and what maybe should be in there.
Yeah, exactly.
That's
Very quick
wow,
too.
that's epic.
Hmm. All right, so now that we're done with kind of like change management, are we seeing any more questions, Dana?
No, not yet, but please keep them coming, guys. We love them.
Okay, yeah, keep them coming. All right, so the next one I have is the final topic for data visualization, and the previous topics for just like the CID comparisons for change management, they all like had some sort of like visualization in here. But in here, I just wanted to like show you how sometimes it's hard to visualize your data in just like a model inside of Revit or inside of your analysis model. So if you export it inside of a CID, you can throw it into any preferred software that you want to use to visualize your data. So the next one is this one is like actually just a screenshot from Revit. You can kind of quickly see the QC your data before it gets pushed into a different model. So like for example, the tops here, it looks like all of the ones in light green have like a data filled out. It could be that everything in the dark green at the very top is missing a data. So like for example, if before you're pushing this into your fabrication model, you want all of the metadata to be correct. So you can either do kind of like a QC check visually inside of Revit, or you can push out this data inside of Navisworks to look at it. Ultimately, you can check this inside of the final program inside of Tekla though, because all of this data is available to you inside the CID, and everything inside of the CID can get pushed into the analysis model or the Tekla model. So then you can also like QC there, but it's also always nice to be able to QC in any of the different models that you create.
Looks like we did have another question actually on Testfoot actually asks, version control in AC is a disaster. How do you keep up with all the changes? How do you track all of that?
That reminds me, that's actually something we're developing right now on the current project that I'm on. So we're calling it kind of like change tracking. So it's all
Perfect.
done through Power BI. Sorry, not Power BI, but like CID comparisons. And like say something changes, it's kind of similar to assigning it a number, like the change tracking. You have your change tracking log, like inside of the log, inside of Excel or something, it says like number 1, like the grade shifted. So then you would go inside of Revit, like assign those numbers that have shifted because of like the grid shift. You would assign it number 1. So then you're right. It's all available inside of the CID, and
Right.
the only thing
Because
that you
once
need to
again, it
refer
just
to is
all comes
that
back
log.
down to that data, right? The more
Yeah.
data we have, the more intelligent we can make our models and overall the SID or whatever it is that we're transporting our data to.
Yeah.
Um,
Exactly.
and maybe it even could be where the comment line just gets aggregated across all the Excel or CSVs, right? And you just compare every single one across the project, and you say,
yeah, definitely.
the CSV on this date has a comment for this member, this index member of this, and that alluded to a significant change in that process, or whatever it might be. Just keeping those, tracking those Excel changes in a sense through Power BI or whatever it is that you're
Yeah.
seeing those changes.
Yeah, exactly. And I think that's the track that we're on now.
Yep. So test fit agrees that both need to be tracked, but it's brilliant to add a comment. It's good work. So absolutely. Yeah, because it's right. It's all down to data. So if I can say this index member or member ID had, XYZ, it has all these properties to it, but let me just go ahead and add a few additional properties, right? We can track anything that we want.
Yeah, exactly. And that goes back to like, everything goes to the Walter P. Moore index. So if you're saying like this Walter P. Moore index, like it changed because of like a mechanical or medical equipment was added to there, then it's really important for the other people in the model to not duplicate that member, because now if you have two members with that, then like the comments get duplicated too. So then now you have like, oh, well, these two members have increased because of the medical equipment that were applied to the room. So it all comes back to like having
like
good
you guys
data and like maintaining it.
It seems like you guys have a really intricate, and there's actually a question coming in about the WPMID for each number. How is that generated? I think it seems like you guys have a pretty unique way and elaborate way, I'm sure, of how each member and each element is identified. But it could probably be, depending on your project and the way that you guys work, maybe developed based off of a concatenation.
Yeah, exactly.
An approximation to a grid intersection or certain things like that, which once again could be automated, but maybe a little harder to track, right? Especially as things move around. How do you ensure that the element that was deleted and the new one that is 6 inches over are the same number, right? So developing that to ensure that WPM index, right? And that's the question. How do we ensure that that's always the same? So how do you at Walter P. Moore develop that number? What is that number or index track back to?
So sometimes, like depending on the project, like the Walter P. Moore index can be really flexible. So what we usually have, you're definitely right, Dana. It's a concatenation. Like all of these, you can see like this first one is a concatenation of all of these ones afterwards, plus a number afterwards. So these kind of different buckets here, these columns tell you different things. So the type, it can be like a column or beam. You can programmatically determine that if you want, like, whether it's vertical, whether it's horizontal, like what it's framing into and stuff. You can determine that programmatically.
Creating a framework of consistency, right, is key, so that
exactly.
You're not getting things numbered and named randomly. Where would that last number come from? So the 27.0, 28.0, where does that value come from?
So that one, the one that I'm generating here, that number comes from when the element was like first modeled. So like you always start from the lowest number and then you make your way up. So like from here, the highest number would probably be like 9,999. But you would only have like those number increment for like the different groups that you're in. So like for here you have, sorry, I like scrolled down. So like for here, you have like the group would be called the columns, and the ARR is at the arrivals level. That's just like the elevation. So every column that's on the arrivals level would get some number, and that number would be assigned based on when the column was first instantiated. So like any new column would take like the greatest number. And what we would say is, say this column got deleted, 27 got deleted. It would never be used again. You can kind of like go back through your SIDs and find out a history. So like if you have like 10 SIDs and like all of a sudden like on the 9th SID, this column disappeared, then it would never be used again. And like those previous 9 SIDs are like the history for that column. And then everything moving forward just kind of like says that, this column never exists again. So that's kind of like how we've
So
been
how
using
would you
the
link?
indexing.
So
Mhm.
let's just say 27 gets deleted and then 999 gets replaced for 27, right? Gets created in its place. How do
Mhm.
you track that 27 and 999 were the same?
So I guess once we're kind of like saying, I guess it's like based on assumptions. So like once you get deleted, what I'm saying is like if it gets deleted and something else gets replaced and it's same, it's not exactly like the same number. It was probably like it's the same number, like it's the same location, but it's back there for like a reason. Like why did the column get deleted first? It's because like something shifted and then like why did it get added back? And it got added back for like a different reason. Then it's kind of like a different column. It may not be like serving the same purpose as it did before.
I see. I see. So if for whatever reason somebody needed to cut and paste to the same place and nothing happened to that number, right? It's the exact same because we sometimes have to do that, right? Sometimes
Yeah.
things act funky in Revit
Mhm.
and things like that need to happen. So we would renumber it the same
Oh,
number, right? Because nothing
yeah.
happened to it.
Yeah,
Okay.
exactly.
And
In
in
those
that case,
cases,
that's
it'd
what
be
you
the
were
same
saying
number.
before, is that you would go
Mhm.
back and you would track, you would compare to the previous data, or in another version of the model generation, wherever that data exists, you could go
Mhm.
back and say, okay, there's that number, it's number 27, and
Yeah,
give it that
yeah,
number.
exactly. And give it the same number.
Perfect.
Yeah.
Awesome. Well, it looks like we have a few more minutes, Eileen. Do you have anything that you want to wrap up on? This has been so fantastic. It's such an amazing, easy
Um,
way to
yeah, thank
Sorry
you.
about the dog.
The last thing that I had, I think that was actually my last slide, but the last slide that I had was a pun. So instead of like a question slide, this is leaving you with a pun.
We love
So
puns.
before like the
Everybody
whole
loves
thing was about
puns.
simplicity, so now it's simplicity.
Oh, I like it. I like it.
Thank
That's
you.
fantastic.
So yep, that's the last slide of the PowerPoint.
Well, thank you so much, Eileen. I hope I didn't bombard you myself with too many questions. It was
No, that was all
so
great.
fantastic, and it's just so fantastic to see all of that interoperability, because
Hmm.
it's something that we're challenged with all the time, right? Architecturally, we have all of these different programs and design and construction and CA and Navisworks, and then later and all of these things. So being able to tie all that back together is so crucial. So thank you so much for presenting today.
Yeah, no problem. Thank you for having me, and thank you for everyone who tuned in. I hope you guys learned something and can kind of develop something similar on your own.
Absolutely. And please join us Thursday for another presentation.